message to London. My first talk happened in 2018. It's been quite a while, but I'm extremely happy to be back again and show you what I did with this project. So to start off, my name is Raf. I'm a senior Java developer in LMAX. Yes, the LMAX from Disruptor. If you know this, if you know Java and you know Disruptor, then and you know Disruptor. LMAX is the company that actually open sourced it, and we are still working on it. And it's a pleasure to work with a bunch of people, bunch of such a brilliant people that actually put this stuff on the market. And yeah, we are hiring. If you want to join us, tell them you know me. I'm also a open source contributor, and that will be the main topic of my talk today. So what's on the agenda? A bit of history, right? How it all started. What happened along the years. I'm gonna have a chat. I'm gonna speak about features. Tell you what was in place in 2018 and what's in place right now, and what's about to be released in Q4 this year. We're gonna have a look at short look at the benchmarks and hopefully do some demo. Speaking of demo, I think I could actually start it right now. There's my pointer. There's the pointer. Actually, this would be better. Right. So the actual demo is literally sending 10 millions of logs at the rate of roughly 50,000 per second. So this should be quite exciting. And how do I switch to this screen again? All right, there it is. Right. And also present you the roadmap for this year and potentially big chunk of next year. I'm planning to release a lot of exciting things. So I hope that you will also be exciting. We're gonna end up with Q&A. So all right, to kick things off, how do we usually use Elasticsearch? We have some sort of application that stores stuff in some kind of storage, like Oracle database or any other database, or disk. It can be disk. Then we use log/beats or log/and-beats to push it to Elasticsearch. But the actual interesting idea is that this is mainly called the Elk stack along with Kibana. But the interesting idea is it possible to do it differently? And what I started to discover in around 2016 at my role as a senior dev in previous company was, is it possible to actually omit log/ and instead of elk go for ek? I'm not trying to put log/ out of business, just to be sure. Right. So it was just a consideration. It was an idea, right? We developed some simple plugin. The design was absolutely horrible. So I asked the company to actually grab this code and release it on my own. And didn't end well. Company didn't agree to that, so I just redesigned it from scratch because the previous design was horrible, absolutely horrible. After the rewrite, it turned out during the testing that a very feasible approach is to actually use some sort of an aggregator between your applications and Elasticsearch, because this approach allows you to utilize the cluster a bit better, I think. Instead of sending thousands of small batches, you can just send it to the aggregator, allow the aggregator to accumulate 5,000 logs, 10,000 logs, millions of logs, split it into batches, and then deliver it from a single source. So, yes, log4j2-elasticsearch. That's how this project came to existence. I was very anxious of it, but because I never did any open source before, so it was a first-time experience for me. But one of my mentors said, if you don't do it, you will never know how to do it, and you will learn along the way. So that's what I did. So what this thing is actually doing in Java, what we can do is we can define loggers. Many other languages also provide their own loggers, but in this particular case, this is a Java library we're going to focus on log4j and how do you interact from the log4j configuration perspective all the way to Elasticsearch ingestion. This will not be a talk about how to search. This will not be a talk how I'm using Elasticsearch. It will be a talk about how you can push your data to Elasticsearch at the rates that are pretty unimaginable. At least I haven't seen any similar message rates on any of the available rally benchmarks or anything similar. And what is my computer doing? Right. So you would like to log some stuff from within your application, right? You say logger info, hello Elastic London. And this log will eventually get serialized to JSON, which more or less looks like this. And then it will get wrapped into a nice bulk API format, but nice batch with bulk API format, where you say what would you like to do with your data, and then provide the data. And you can do it thousands of times in a single request before you send it out. Bulk API. Does anyone doesn't know bulk API? Good. So it started very simple. It was just a simple XML snippet, which ought to do be a lot of XML form right now. A very simple snippet, basically few lines, 10 lines of code in your log4j configuration, which allow you to use loggers to actually and appenders to eventually send your data to Elasticsearch exactly from within your application. Sounds great, but there is one risk. You put all of the potential allocation that comes out from the serialization of your logs from Logstash or anything that actually delivers your stuff to yes. You're moving all of this workload inside your application, which raised some red flags for me. But I'm gonna tell you how I dealt with that soon. And indeed, the actual design at the beginning could be easily described like this. We have some appender adds stuff to the batch delivery. Batch delivery, once it reaches a certain size, it sends out a batch of logs with HTTP client to Elasticsearch. And it was all working great. And I had a roadmap in 2018, which, in the retrospect, was delivered roughly a few months after, and it was massively extended. This project right now can be, for instance, defined by this XML as well, which I didn't anticipate. But all of these features, this is probably roughly a half, or maybe 2/3 of all the features that are currently available. So let's have a quick rundown of what's going on, and what happened since 2018. I believe that at that point I already had supporting index templates. However, in 7x, some of the URIs were deprecated. Component templates came into play. ILM came into play. All great stuff. So this sort of integration is already available in version 1.5, already released. You can already use it. What you can do with this particular plugin once your application starts, you can tell what sort of mappings you would like to have, what sort of rollover policy, ILM policy, what sort of rollover aliases you would like to use for your index, and just start sending your data directly from ES. It's more or less what Logstash is doing, just very, very, very carved down. Right, support for data streams will be available in the last quarter of 2022. I really wanted to get it ready for today, but unfortunately, there's a lot of testing involved. Data streams will be definable probably roughly right like this. And also, of course, since the very inception of this project, integration with bulk API and eventually nodes API to get service discovery, to introduce service discovery and react to the failures of your nodes. Speaking of the core features of this plugin, outside of Elastic, one of the biggest concerns of you at the very beginning of this project was what is happening to my logs if the Elasticsearch cluster fails. So a very simple design became a bit more complicated, but eventually the failover policy backed by Chronicle Map was introduced, and a retry processor that picks up all the failed logs from Chronicle Map and delivers them back to batch delivery in a separate thread should be enough to address some fairly low volume deliveries. Service discovery that I mentioned allows you to refresh the list of available nodes every interval of your choice. And the feature that I'm most proud of is the object pooling. So the actual design that you saw before could be extrapolated to this, or described like this as well. We have some serialization at the very beginning. We are serializing our log events, adding the serialized log event to the batch delivery into the in-memory store, notifying the listener when 1 second passed, 10 seconds passed, or when the batch limit was reached. Wrap it with serialize it to a batch, and deliver it to the HTTP client. And this is more or less how Jest module architecture looks like. There's a log4j Elasticsearch Jest, and the new module optimized, very heavily optimized, called HC, stands for HTTP components, because that's the HTTP client it's based off. So with this architecture, you're allocating a lot. How much, you wonder? Well, Jest allocates roughly, I think in 1.0 or 1.1, it was allocating roughly 20 gigabytes of memory per 1 million logs, which is quite a lot. So this situation was addressed by good old object pooling that a lot of developers forgot. But what it allows you to do is to provide some mutable data structures for your runtime, so that you don't have to allocate big strings, big whatever. You can serialize your logs directly into the buffer, which you will then return to your pools after the HTTP request is finished. So you allocate once per deployment, theoretically. However, given that these pools are resizable, they're gonna expand and shrink on demand. It's not 100% true, but for the sake of argument, you allocate once. So as a result, it was around 9 gigabytes per million. So in comparison, this is the approximation, because obviously I don't have 100 gigabytes of my available memory on my laptop, but this is the summary of the whole memory allocated while delivering 10 million logs. Elasticsearch HC is available. Is obviously should actually be your library of choice. I know you love Jest simplicity, and I see a lot of traffic on how to use Jest and how to use all of these features. However, HC modules has a bit higher traffic, which is very good, because you're also after performance in some cases, which is very much appreciated. And HC module will be the main module that will be developed in the future. You're also capable of fully configure your JSON output with some Jackson with some Jackson faster XML tricks, you could define this bit of log4j configuration to actually add some field 1 and field 2 to your Jackson payload, and the log you're producing should include both of those fields, assuming that this value is not empty. Interesting. So this is great. You can decorate your outputs in runtime, right? Does any one of you use this feature by any chance? Okay. The next very big feature, which I've put a lot of effort into, is metrics. By metrics, I mean all of the batch delivery parameters that would be important for you to actually figure out what's going wrong with my application and what is the tipping point of this particular configuration. How much you can push your cluster before it starts to reject your messages, and how many messages got rejected, how many messages got sent. Statistics of your buffer pools. This is very close to release. Should be released next month, hopefully. And very much very much appreciated. I hope if you find any issues, please raise them on GitHub. So at the very first release, the only available option for you will be to log it with metric log, which will result more or less with output like this. What would I really like to do, and what I already have developed, is just still has some rough edges, needs to be worked on, is actual delivery to Elasticsearch, because we all love to push stuff to ES, right? So you can eventually produce dashboards like this, or any type of dashboards you want. Dashboard will not be a part of this release. However, the data shipped over that will absolutely will. We'll be able to identify our HTTP client and figure out how many items were sent, how many items were delivered, how many items failed, pull statistics, so on and so forth. So this is the overview of actual delivery of 10 million items. I'm trying to avoid logs, because what I'm trying to build is not only about logs, it's not only about Elasticsearch, it's more about batches and batch items. So we deliver 10 million items, which in case of log4j2-elasticsearch actually means 10 million logs, but I'm going to use items from now. So this is actually a delivery of 10 million items in roughly 4 minutes. Well, actually, just slightly above 3 minutes, at the rate of roughly 50,000 per second. This is a view per 10 seconds. You can see, if you can see, it's 200,000 mark on the left. So that's what it does, and 200,000 sounds great, but I was definitely not happy about 50,000. I would really like to know how fast this plugin can actually go. So I developed a few benchmarks and got some rough numbers. What is theoretically possible with the current design? So headers on top represents the actual size of the message. On the left, you have a batch size, and how many gigabytes per second could you actually transfer. When you see numbers like 12 gigabytes per second, these are actual gigabytes and gigabits. When you see that you can transfer 12 gigabytes per second, you wonder, do I have the network in there? Do I have any NIC that will actually consume this data? So if you have any 100 gigabit NICs lying around, please call me. I would really like to test it. Also, this is the benchmark where the actual data is not shipped to final buffer in the HTTP client, which after some testing shows that these numbers should be chopped, it should be carved by 20%, maybe a third, to actually represent actual possibilities, true potential of this thing. So if you get 6 gigabytes of 16 kilobytes message per second, that's quite cool, I think. With increased batch size, the parameters change a bit. However, also some runtime parameters are getting a bit better, because I'm still fighting allocation, and I'm still working on getting this thing close to close to garbage free. But this will still take maybe a year or two to actually complete. If you'd like to run this test, there's the name on top. It should be master already. So this is all great, but I still didn't test it live. So the actual possibility, real life possibility came when I joined LMAX. Or actually a few years deep, because the first testing was done this year. So a real life scenario that we do have in LMAX. This will be a tiny bit about how we consider using Elasticsearch, to be honest. So we have a very high traffic. LMAX is a foreign exchange. We are trading currency pairs. We are trading crypto, which means that our traffic is quite high. We have vast amount of real-time data. By vast amount, I'm talking well, right. If terabytes per day, several terabytes per day are okay, are vast enough for you raise your hand. If you have higher traffic, raise your hand. However, it would be close to impossible to actually ingest it in real time. And what we would really like to do in some cases is to just take a peek at some data, because something was off at this particular second or microsecond in time. So we would like to say, I would like to get this small chunk of data, like 100 gigs, 200 gigs, representing some few minutes, tens of minutes, or some hours of our production, let's call it story. And we would like to just have a look at it and forget it, right? We found the issue. We know what's going on. We can forget about this data, right? Storing it in Elasticsearch would be vastly inefficient due to the storage parameters. So if we can go faster than X per second, X documents per second, that means that we can grab a chunk of data, maybe even 24 hours of data, and ingest it to Elasticsearch quicker than 24 hours. That would be ideal. If it takes more than a day to ingest 1 day of data, that's not really makes sense. That doesn't really makes a lot of sense. So I was blessed with a fantastic infrastructure team, which provided me with a tiny deployment of three nodes. Each one of these nodes has 64 CPUs and 128 gigs of RAM. A quarter of it goes to Elasticsearch, along with recommendations, around 30 gigs, all backed by NVMe drives. So I tried to run it with no replicas, all of the parameters that would allow me to ingest it as fast as possible. The actual documents had a roughly 150 to 200 bytes, not a big one, but eventually I got to a point where I could ingest 450,000 documents per second, which is good, but I ran out of pipe because I only had 1 gigabit interface to use. So I know that this software can spit out 450,000 documents per second. Elasticsearch can easily ingest it, which is good, which means that I have some. If the cluster has some wiggle room, I have some wiggle room for sure. So once I get to test it with a bit bigger, a bit wider pipe, so to say, maybe we will eventually deliver 1 million, maybe 1.5, 2 million, or 2 millions of documents per second, which will make sense with the amounts of data that we are interested in. Any questions? Okay. And this basically stops us from proceeding at this point, because I still don't have all the features. These numbers were achieved with some hacked developer version of my code, which I'm slowly releasing to master, and you should see a few interesting commits in the next weeks that would allow you to easily support 500,000 documents per second, probably more. So what's there on the roadmap? In the next release, 1.6.0, Elasticsearch 8 compatibility is a must. Is a must at the moment. I'm very late with that, but I'm focusing a lot. Like the main part of my focus was to get some performance improvements in. Forgetting about your users. Terribly sorry for that. But Elasticsearch 8 compatibility is a few hours from committing, probably a few weeks from releasing. So if you're interested, I highly recommend you to check it out. Also, one of the milestones will be achieved in 1.6. You will be able to run this code without log4j. Log4j2 has some overhead. If you can use this plugin, this library with a completely programmatic option, which allows you to use some features that are unavailable with ES, like backups and some smarter treatments of your logs. Also, 1.6 will contain metrics. I should be able to ship those metrics to ES at some point next year, I hope. Probably, maybe this year. We'll see. Another version, 1.7, should contain a final refactoring before log4j Elasticsearch is split into two modules. The log4j Elasticsearch will become a module that contains all of the log4j configuration, so that you can play around with your XMLs and ship your logs from the application. But the actual gold that is hidden over there at the moment is the layer that allows you to run it standalone, and all the batching logic that allows you to send gigabytes of data, assuming that you have a pipe that is wide enough. So this will become a completely separate module, which will enable plugins like log4j to Splunk, or log4j to anything, or logstash to anything, or whatever else you imagine. Most probably the most efficient batcher in the world, I hope. If you have any faster batchers, ping me. I'll happily set up some sort of benchmarks. How's our demo? Right, so the main point of this demo, yes. Right. So the main point of this demo was to ship 10 million items, and it got completed in a few minutes. Where you could see some statistics of the item pool, and also some stats around how many items were delivered. Right, the goal was achieved 100%. That's good. 10 million items delivered, and the maximum that server took was 139 seconds. And this is just a chunk of metrics that will become available with 1.6 release. And I think that brings us very close to the end of this talk. And that's definitely the slide I want it to be in. Ah, there it is. This will work. Come on. Questions? So far, this is all I have for you. Unfortunately, yes.
Yeah, sorry, I don't want to hold you for too long because you've got less than such a capability to sort out tonight. But so I missed the introduction. So is this your personal project, and then you started working with LMAX?
Yes.
So what's your license model now?
So at the moment it's APL 2.0, and most of the features will be APL 2.0. If I eventually make it a commercial product, which I'm considering, I don't know what sort of types of commercial features I would offer. So far everything is available in open source. You can use it, you can improve it, and share your experience. At the moment, yeah, it's completely open source. So have a crack at it. Take a stab at your cluster. Warn the sysadmins, this thing can go very, very fast. How many of you are ingesting more than 10,000 documents per second?
Under some use cases. Yeah.
More than 100,000?
Financial data.
Yeah. So I reckon you're probably you could go 500,000, 1 million per second easily.
In bursts.
Yes. So this thing can help you out. I would recommend Post. I wouldn't recommend real-time ingestion because there are not a lot of backup mechanisms in this thing. So you may lose your logs along the way.
How far back does version compatibility of Elasticsearch go?
Down to 2. It's compatible with 2, compatible with 7, all the versions along the way. Also, Elasticsearch 8 compatibility coming out soon, so you have all the choice. And the plugin of choice that I would recommend is log4j2-elasticsearch HC, which is a optimized Apache HTTP components library. I will also release a component called AHC, which is based on the async HTTP client that supports XZIP, because unfortunately Apache HTTP doesn't in async mode, which is a shame. Not even the latest 5.0 version. So and I don't think they're planning on adding XZIP in async mode to their feature list anytime soon. So given that I was running out of pipe, I developed AHC module. Eventually got to 450. Ran out of pipe again. Now I'm just waiting for the wider for bigger, better bandwidth. If you would like to ingest your financial data, we are in the very similar spots. Any other questions? All right. Thank you very much.